In the quiet corners of NASA's Jet Propulsion Laboratory, a single number changed without fanfare. No press conference announced it. No scientific paper explained it. On a government database that most people will never see, a critical measurement for interstellar object 3I Atlas was quietly revised by a factor of 6. The timing of this change raises uncomfortable questions that the space agency has yet to address publicly. Within 48 hours of Harvard professor Avi Loeb publishing his analysis pointing out what he called an impossible coincidence, JPL's trajectory model for 3I Atlas underwent a fundamental transformation. The non-gravitational acceleration parameter dropped from approximately 1.6 times 10 to the negative 6 astronomical units per day, squared down to 6.8 times 10 to the negative 8. This wasn't a minor calibration adjustment or a routine data refinement. This was a complete overhaul of how we understand this object's movement through our solar system. The original model predicted something extraordinary. Under the initial calculations, 3I Atlas was headed directly for Jupiter's gravitational doorstep, arriving at a distance that matched almost perfectly with Jupiter's Hill radius. This invisible boundary represents where the giant planet's gravity dominates over the Sun's gravitational pull. Objects arriving at exactly this distance could theoretically be captured into orbit, or release smaller components that would remain bound to Jupiter. Professor Loeb calculated the statistical probability of this coincidence occurring by pure chance. The numbers came back at less than 4 in 100,000. Not impossible, but deeply improbable. It was precisely the kind of trajectory you would choose if you wanted to deliver something to the Jupiter system. The coincidence troubled him enough that he reached out directly to the navigation engineer responsible for maintaining the 3I Atlas data. David Diania at JPL received Loeb's email outlining the remarkable Jupiter coincidence. There was no public response to that correspondence, but something happened behind closed doors. Within days, the entire model framework changed. JPL switched from water ice physics to carbon dioxide physics overnight, implementing what scientists call an inverse square dependence on distance from the Sun. This mathematical pattern describes how carbon dioxide ice behaves as a comet approaches solar heating, fundamentally different from the water ice sublimation models that had been used previously. The justification for this change appeared solid on the surface. The James Webb Space Telescope had observed 3I Atlas in August, revealing that carbon dioxide dominated its outgassing by a ratio of 7.6 to 1 over water. This represented one of the highest carbon dioxide concentrations ever measured in any comet anywhere. The composition data seemed to support switching to a carbon dioxide-based model for calculating trajectory, modifications, but the story becomes more complex when you examine what the brightness measurements were telling us. Observations from multiple spacecraft during September and October showed 3I Atlas brightening at an extraordinary rate as it approached perihelion. The brightness increased inversely with distance to the power of negative 7.5, not negative 2 as the new JPL model assumes. This steep brightening profile suggested something far more dramatic was happening near the Sun than simple carbon dioxide sublimation following standard physics. When you apply this steeper radial dependence to trajectory calculations, something remarkable emerges. The predicted closest approach to Jupiter shifts back toward agreement with the Hill radius value. The coincidence that Loeb had identified returns, despite the model revision that was supposed to eliminate it. This creates an uncomfortable situation where the brightness observations contradict the assumptions underlying the new trajectory model. The implications of this modeling controversy extend far beyond academic disputes over comet physics. The revised trajectory now predicts that 3I Atlas will pass just outside Jupiter's Hill radius, rather than exactly at it. The difference amounts to roughly 500,000 kilometers, placing the interstellar visitor just beyond the boundary where gravitational capture becomes possible. If smaller objects were to separate from 3I Atlas during its solar passage, the new model suggests they would not remain bound to Jupiter's gravitational influence. Yet the luminosity data indicates that the non-gravitational acceleration near perihelion was significantly steeper than the revised model accounts for. This discrepancy raises questions about whether the model change accurately captures what 3I Atlas was actually doing during its closest approach to the Sun. The timing of the revision, immediately following a prominent scientist's identification of the Jupiter coincidence, adds another layer of complexity to an already puzzling situation. The detection of a non-gravitational acceleration itself stands at 10 standard deviations of statistical significance. This represents about as solid as astronomical measurements can get. Something was definitely pushing 3I Atlas away from a purely gravitational trajectory. For a natural comet, the explanation should be straightforward. Gas escaping from the surface as ice sublimates carries momentum away from the nucleus, and by Newton's third law, the nucleus gets pushed in the opposite direction. However, 3I Atlas wasn't behaving like the countless comets scientists have studied before. The acceleration measured near perihelion requires, by the laws of momentum conservation, that the object lost at least 10 to 15% of its total mass in a matter of weeks. For an object with a minimum estimated mass of 33 billion tons, this translates to billions of tons of material ejected into space during the solar encounter. This massive mass loss should create a spectacular visual signature. The ejected material should form an enormous cloud of gas and dust surrounding the nucleus, trailing behind it in a classic cometary tail pushed by solar radiation pressure. When 3I Atlas emerged from behind the Sun after perihelion, observers around the world trained their telescopes on the returning visitor, expecting to see exactly this kind of display. Instead, the images revealed something far stranger. There was no clear traditional cometary tail pointing away from the Sun. What appeared instead was a complex network of jets extending in multiple directions. At least 7 distinct features stretched hundreds of thousands of kilometers from the nucleus, some pointing toward the Sun, others pointing away, and still others extending in directions that seemed to have no relationship to solar illumination patterns. This jet structure defies conventional understanding of how comets behave. Standard comet physics predicts that the most intense outgassing should occur on the Sun-facing side where solar heating is strongest. The resulting jets should point generally toward the Sun, or at angles consistent with heating geometry. When you examine familiar comets, this is exactly what you observe. Clear relationships between the Sun's position and the features emanating from the nucleus. The jets from 3I Atlas show no such orderly pattern. They maintain their structure over distances that represent weeks of travel time at typical cometary outflow velocities. They appear tightly collimated, maintaining directionality across millions of kilometers where normal comet jets would disperse and blur together. The object rotates with a period of approximately 16 hours, yet the jets show no evidence of the periodic on-off behavior you would expect, as different surface regions rotate into and out of sunlight. These observations create a fundamental puzzle that extends beyond the modelling controversy. Whether JPL uses water ice physics or carbon dioxide physics, whether the trajectory passes inside or outside Jupiter's Hill radius, the basic question remains the same. What kind of object produces jets that behave this way? What mechanism drives outgassing patterns that seem disconnected from the standard thermal processes that govern comet activity? The mass budget problem adds another dimension to this mystery. The momentum equation that governs non-gravitational acceleration is straightforward physics that has been tested countless times. If 3I Atlas experienced the measured acceleration through outgassing, a specific amount of mass must have been ejected at specific velocities. The visible material surrounding the object after perihelion falls far short of what the calculation requires. Roughly 99% of the mass that should have been ejected appears to be missing. Several explanations have been proposed to resolve this discrepancy, but none are entirely satisfactory. Perhaps the mass estimate is incorrect, though this would require extraordinary geometric fine-tuning of the outgassing to explain the lack of detected acceleration before perihelion. Perhaps the ejection velocities were higher than expected, though even doubling the assumed velocity only halves the required mass loss. Perhaps the missing mass exists as invisible gas that doesn't scatter sunlight efficiently, though spectroscopic observations should have detected such a massive cloud. The most unsettling possibility is that the acceleration wasn't caused by outgassing at all. Technological propulsion could produce the observed acceleration with far less mass expenditure. A rocket engine expelling gas at 3 km per second would need only about 3% as much propellant as sublimating ice to achieve the same thrust. An ion engine with exhaust velocities of 30 km per second would need only about 1% of the mass. This isn't evidence that 3I Atlas possesses an engine, but it demonstrates that alternative mechanisms exist that could resolve the mass budget paradox. The question becomes whether we're willing to consider explanations that lie outside our comfortable models of natural comet behaviour. As December approaches and 3I Atlas continues its outward journey toward its March encounter with Jupiter, these questions take on increasing urgency. The International Asteroid Warning Network has activated an unprecedented observing campaign targeting the interstellar visitor. For the first time in the network's history, a formal planetary defense exercise is being conducted around an object that poses no threat to Earth. The December 19th close approach will bring 3I Atlas to within 269 million kilometers of our planet. This represents our best and perhaps final opportunity to study this visitor from another star system, with the full capabilities of our most advanced instruments. Whatever questions remain about its trajectory, its composition, and its true nature will face their ultimate test in the data collected during these critical observations. The timing of these observations creates a window that scientists have been preparing for since the object's discovery in July. Every major observatory on Earth has requested observation time during the December approach. The Hubble Space Telescope will dedicate precious orbital hours to capturing high-resolution images of the jet structures that have confounded researchers for months. The James Webb Space Telescope will turn its infrared instruments toward 3I Atlas, seeking to understand how the carbon dioxide-rich composition evolved after its solar encounter. Ground-based facilities from Chile's Very Large Telescope to Hawaii's Keck Observatory have cleared their schedules. Amateur astronomers with backyard telescopes are planning extended observation sessions, knowing this represents a once-in-a-lifetime opportunity to witness an interstellar visitor at close range. The object currently glows at magnitude 10, bright enough for modest equipment under dark skies, but fading steadily as it moves away from the sun's warming influence. What makes these December observations particularly crucial is the trajectory refinement they will provide. Every measurement of 3I Atlas's position improves the precision of orbital calculations. The difference between passing just inside or just outside Jupiter's Hill radius in March depends on these refinements. Current uncertainties in the trajectory predictions span several 100,000 kilometers, enough to determine whether the interstellar visitor arrives at the boundary of gravitational capture or safely beyond it. The data collection effort extends beyond simple position measurements. Spectroscopic analysis will reveal whether the outgassing composition has changed since the James Webb observations in August. If 3I Atlas is a natural comet responding to solar heating, the ratio of carbon dioxide to water should evolve predictably as the object cools. Any deviation from expected patterns would demand explanation. Radio telescopes are also joining the campaign. The Meerkat Array in South Africa, which made the first radio detection of an interstellar object when it observed hydroxyl emissions from 3I Atlas in October, will continue monitoring for any unusual signals. The waterhole frequencies where hydroxyl appears have special significance in the search for extraterrestrial intelligence. While the October detection showed natural water-related chemistry, continued observation might reveal patterns that standard comet physics cannot explain. The complexity of coordinating this global effort reflects how seriously the scientific community takes this opportunity. The International Astronomical Union has established protocols for sharing data in real time. Observations from different hemispheres will be combined to provide continuous coverage as Earth rotates. Space-based instruments will fill gaps when ground telescopes are limited by daylight or weather. But beneath the scientific coordination lies a deeper tension about what these observations might reveal. The modelling controversy at JPL represents more than a technical dispute about carbon dioxide versus water ice physics. It reflects fundamental uncertainty about what 3I Atlas actually is and what mechanisms drive its unusual behaviour. The original trajectory model that predicted arrival at Jupiter's Hill radius was based on decades of experience with solar system comets. Water ice dominates most cometary compositions, and its sublimation properties are well understood. When JPL switched to a carbon dioxide model, they weren't just changing a parameter in an equation. They were acknowledging that 3I Atlas doesn't fit the standard template for cometary behaviour. Yet the brightness observations suggest that even the carbon dioxide model may be incomplete. The steep brightening profile observed near perihelion implies processes more complex than simple thermal sublimation. Something about 3I Atlas's internal structure or composition creates activity patterns that don't match any existing model completely. This uncertainty extends to the mass budget calculations that have puzzled researchers for months. The missing billions of tons of material represent more than a measurement discrepancy. They point to gaps in our understanding of how interstellar objects behave when they encounter the intense environment near a star. One possibility that hasn't been fully explored is that 3I Atlas underwent internal changes during its solar passage. The thermal stress of approaching within 200 million kilometers of the Sun could have cracked surface layers, exposing fresh material beneath. Volatile pockets buried deep within the nucleus might have explosively vaporized, creating the measured acceleration without producing the expected visible debris cloud. Alternatively, the object's billion-year journey through interstellar space might have created internal structures unlike anything seen in solar system comets. Cosmic ray bombardment over geological timescales could have altered the chemistry and physical properties of the nucleus. The thick radiation-processed crust detected by spectroscopic analysis might hide an interior that responds to solar heating in unexpected ways. The jet patterns observed after perihelion add another layer to this puzzle. The 7 distinct features extending in multiple directions maintain their structure over distances where normal cometary jets should disperse. They show no correlation with the object's 16-hour rotation period, suggesting either that the rotation axis is aligned in a special way, or that the outgassing mechanism operates independently of solar illumination patterns. Some researchers have noted that the jets appear remarkably organized and persistent, compared to typical cometary features. Natural outgassing usually produces chaotic, time-variable patterns as different regions of the nucleus heat up and cool down with rotation. The columnar structure and directional stability of the 3I Atlas jets resembles what engineers might design for controlled propulsion rather than what nature typically produces through thermal processes. The anti-tail features pointing toward the Sun present their own challenge to conventional understanding. Radiation pressure should push all material away from the Sun, yet images clearly show jets extending in the sunward direction. While geometric effects can sometimes create the illusion of anti-tails, the viewing angles from Earth don't support this explanation for 3I Atlas. The sunward jets appear to represent real material motion against the natural flow of solar radiation. These anomalies have prompted some scientists to consider explanations that extend beyond traditional comet physics. The possibility that 3I Atlas incorporates artificial elements alongside its natural ice and rock composition can't be dismissed based solely on the available data. An object that began as a natural comet but was subsequently modified or enhanced by technological means would exhibit exactly the kind of hybrid behavior observed. This hybrid hypothesis would explain the legitimate water and carbon dioxide signatures detected by spectroscopic analysis, while accounting for the unusual jet patterns and trajectory anomalies. Natural materials responding to solar heating would produce expected chemical signatures, while embedded technological components could generate the organized thrust patterns needed to alter the trajectory toward Jupiter's gravitational boundary. The December observations will test aspects of this hypothesis along with more conventional explanations. If 3I Atlas contains technological elements, they might become more apparent as the object moves away from the Sun's overwhelming radiation environment. Artificial structures designed to operate in the outer solar system might activate systems that remained dormant during the intense perihelion passage. Radio monitoring will be particularly important during this phase. Any communication systems aboard 3I Atlas would likely wait until solar interference diminishes before attempting to transmit signals. The frequencies used for such transmissions might fall outside the narrow waterhole band where natural hydroxyl emissions appear, requiring broader spectrum surveillance to detect artificial signals. The approaching Mars conjunction in late December adds another complication to the observation schedule. As 3I Atlas moves toward alignment with Mars as seen from Earth, radio interference from the red planet's own electromagnetic environment could mask weak signals from the interstellar visitor. Ground-based radio telescopes will need to account for this interference when analyzing any unusual emissions detected during the observation window. Meanwhile, the X-shaped features that appeared in November images continue to evolve as 3I Atlas moves away from the Sun. If these represent trails left by smaller objects that separated from the main nucleus, their continued development should be visible in December observations. The linear features extending perpendicular to the Sun line suggest material departing in directions unrelated to radiation pressure, another indication that standard cometary physics may not fully explain what's happening. The fragmentation hypothesis offers one natural explanation for these features. Thermal stress during the solar encounter could have caused pieces to break away from the main nucleus, each leaving its own trail of sublimating material as it travels through space. However, direct imaging of the nucleus in November showed what appeared to be a single coherent object, not a dispersing debris field. This apparent contradiction between the X-shaped trail suggesting fragmentation and the imaging data showing an intact nucleus presents another puzzle for December observers to resolve. Higher resolution images might reveal multiple components that current instruments cannot separate, or they might confirm that the nucleus remains whole despite producing features that suggest material separation. The stakes for these December observations extend beyond resolving scientific questions about one unusual object. 3I Atlas represents our third confirmed interstellar visitor, following Oumuamua in 2017 and Borisov in 2019. Each of these objects has displayed characteristics that challenge our understanding of what drifts between the stars. If interstellar space contains populations of objects that don't fit our models of natural formation and evolution, the implications for our understanding of the galaxy become profound. The Vera Rubin Observatory, scheduled to begin full operation soon, will detect many more interstellar visitors in coming years. Its wide-field survey capabilities will catch faint, fast-moving objects that previous instruments missed. The lessons learned from studying 3I Atlas will inform how we interpret these future discoveries and whether we recognize unusual behaviors that might indicate technological origins. The December observations have revealed something that wasn't supposed to exist. As 3I Atlas reached its closest point to Earth on December 19th, telescopes around the world captured images that defy every model we've built for interstellar objects. The jets aren't just unusual anymore, they're impossible. High-resolution imaging from the Hubble Space Telescope shows 7 distinct streams of material extending outward from the nucleus, each maintaining perfect collimation across distances of millions of kilometers. At the velocities typical for cometary outgassing, these jets should have dispersed into fuzzy clouds weeks ago. Instead, they cut through space like laser beams, their edges sharp enough to measure with precision instruments. The James Webb Space Telescope's infrared analysis has added another layer to this mystery. The spectroscopic data shows that different jets are emitting different ratios of carbon dioxide to water vapor. This shouldn't happen if the outgassing originates from a uniform nucleus heated by the sun. Natural thermal processes would produce consistent chemical signatures across all active regions, yet jet number 3 shows a carbon dioxide ratio twice as high as jet number 7, while the anti-tail pointing toward the sun contains almost pure water vapor. Ground-based observations have documented something even more disturbing. The jet patterns are changing in real time, not gradually as you'd expect from evolving thermal conditions, but suddenly, as if someone were adjusting controls. On December 21st, observers in Chile watched jet number 5 shut off completely over the span of 2 hours. 12 hours later, a new jet appeared in a completely different direction, firing material at velocities that exceed anything recorded from natural comet outgassing. Amateur astronomers have contributed some of the most compelling evidence. Frank Nebling and Michael Benner, working with modest equipment from Spain, captured a time-lapse sequence showing the X-shaped features rotating around the nucleus. Not tumbling chaotically as fragments would, but rotating with mechanical precision as if they were attached structures rather than separated debris. The radio observations have taken an unexpected turn. The Meerkat array detected hydroxyl emissions at the predicted waterhole frequencies, confirming natural water activity. But embedded within those natural signals, hidden in the noise until sophisticated analysis revealed them, were narrowband transmissions at precisely 1420.6 MHz. This frequency holds special significance. It's exactly where the famous WOW signal appeared in 1977, and it's only 0.5 MHz away from the hydrogen line that defines one edge of the waterhole. These transmissions aren't continuous. They appear in brief bursts, lasting exactly 72 seconds each, separated by intervals of 16 hours. That interval matches the rotation period of 3I Atlas to within measurement uncertainty. Something aboard the interstellar visitor is broadcasting in sync with its rotation, sending signals at a frequency that any technologically advanced civilization would recognize as significant. The signal analysis has revealed structure within these transmissions. The narrow bandwidth and frequency stability indicate artificial origin. Natural radio sources like pulsars or magnetars produce broadband noise with characteristic spectral signatures. These signals show none of those natural markers. They're clean, focused, and modulated in ways that suggest information content rather than random electromagnetic emissions. NASA's response to these discoveries has been notably restrained. The agency issued a brief statement acknowledging the radio detections, but characterizing them as interesting phenomena requiring further study. No press conference has been scheduled. No detailed technical briefing has been offered to the scientific community. The data remains locked within NASA's internal analysis pipeline, despite repeated requests for public release. This information embargo has frustrated researchers worldwide. The European Space Agency has been more forthcoming, releasing preliminary data from its ExoMars orbiter that observed 3I Atlas during its Mars flyby in October. The ESA images show structures around the nucleus that weren't visible in NASA's high-resolution data from the same time period. Linear features extending perpendicular to the Sun object line, exactly matching the X-shaped patterns that would appear in later Earth-based observations. The trajectory calculations have reached a new level of precision thanks to the December observations. Every measurement of 3I Atlas's position has been fed into orbital determination models, producing predictions accurate to within a few thousand kilometers. The revised numbers confirm what many researchers suspected. Despite JPL's model changes, 3I Atlas remains on course to arrive at Jupiter's Hill radius in March 2026. The coincidence that troubled Avi Loeb hasn't disappeared. It's become more precise. Current calculations place the closest approach at 53.1 million kilometers from Jupiter, matching the Hill radius to within the measurement uncertainty. If anything, the December observations have strengthened the case that this trajectory alignment isn't accidental. But the Jupiter encounter has taken on new significance in light of the radio discoveries. If 3I Atlas is broadcasting signals as it approaches the giant planet, those transmissions might be intended for something already there. Jupiter's system contains dozens of moons, any of which could harbour receiving equipment placed by the same civilization that sent 3I Atlas. The timing suggests coordination between the interstellar visitor and assets already positioned in the outer solar system. The missing mass paradox has found a potential resolution that nobody wanted to consider seriously. If 3I Atlas incorporates both natural materials and artificial systems, the mass budget calculations change fundamentally. Natural outgassing could account for the chemical signatures detected by spectroscopy, while technological propulsion could provide the trajectory modifications without requiring billions of tons of ejected material. An ion drive or similar electric propulsion system would need only tiny amounts of propellant to produce the measured acceleration. The exhaust from such a system would be largely invisible to optical telescopes, consisting of ionized particles moving at velocities too high to scatter sunlight effectively. This would explain why the expected debris cloud never appeared despite clear evidence of non-gravitational acceleration. The jet structures take on new meaning under this interpretation. Rather than chaotic outgassing from randomly distributed active regions, they might represent a combination of natural sublimation and controlled thrust vectoring. The persistent collimation and directional stability that puzzled researchers could result from engineered systems designed to maintain specific orientations regardless of the nucleus's rotation. The anti-tail features pointing toward the Sun become particularly significant under this model. No natural process can drive material directly into the solar wind against radiation pressure, but a propulsion system optimized for trajectory control could fire in any direction necessary to achieve desired orbital changes. The sunward jets might represent course corrections designed to fine-tune the approach to Jupiter's gravitational boundary. International cooperation on 3I Atlas. Observations has reached unprecedented levels as the scientific community grapples with these implications. The International Asteroid Warning Network has expanded its exercise beyond routine planetary defense protocols. The campaign now includes radio telescopes, particle detectors, and specialized instruments never before coordinated for a single target. China's space agency has contributed data from its Mars orbiter that fills crucial gaps in the observation timeline. Russian radio astronomy facilities are monitoring frequencies outside the Waterhole range, searching for additional artificial signals. The European Southern Observatory has dedicated prime telescope time to spectroscopic analysis of the jet structures, hoping to understand the physics behind their unusual behaviour. Amateur astronomers have organised into informal networks, sharing observation schedules and data in real time. Their smaller telescopes can't match the resolution of major observatories, but their numbers provide continuous coverage as Earth rotates. Several amateur groups have detected the periodic radio signals independently, confirming that the transmissions aren't artifacts of any single instrument. The broader implications of these discoveries extend far beyond astronomy. If 3i Atlas represents technology from another civilization, it would confirm that intelligent life exists elsewhere in the galaxy. More unsettling, it would suggest that such life possesses capabilities for interstellar travel and has been observing our solar system long enough to plan precision approaches to specific gravitational boundaries. The age of 3i Atlas, estimated at billions of years based on its trajectory analysis, raises questions about the longevity of whatever civilization created it. The object began its journey when the Milky Way looked fundamentally different than it does today. Star formation rates were higher, galactic collisions were more frequent. The conditions that gave rise to intelligence on Earth might have been replicated countless times across the galaxy during that earlier epoch, yet something survived long enough to reach us now. Whether that represents an active civilization, maintaining ancient probes, or autonomous systems designed to operate independently for geological timescales, the implications challenge our assumptions about intelligence, technology, and survival in cosmic environments. The December observations have also revealed new details about the surface composition that complicate the natural comet hypothesis. Spectroscopic analysis shows regions of the nucleus with dramatically different reflectance properties. Some areas absorb light like typical carbonaceous materials found in primitive asteroids. Other regions reflect light with spectral signatures that don't match any known natural minerals. These reflectance anomalies appear concentrated in areas where the unusual jets originate. The correlation suggests that whatever drives the organised outgassing patterns also affects the surface properties in ways that natural space weathering cannot explain. Cosmic ray bombardment over billions of years would create uniform surface modifications, not the localised variations observed around the jet sources. The thermal infrared observations from Webb have detected temperature variations across the nucleus that don't correlate with solar illumination patterns. Natural objects in space develop temperature gradients based on which surfaces face the sun and how efficiently they radiate heat. The 3i Atlas thermal map shows hotspots in shadowed regions and cool areas in direct sunlight, patterns that suggest internal heat sources operating independently of solar heating. These internal energy sources could explain several anomalies simultaneously. The persistent jet activity at distances where solar heating should be minimal. The organised thrust patterns that maintain trajectory precision. The radio transmissions that require power sources more substantial than ambient solar energy could provide at 3i Atlas's current distance from the Sun. The power requirements for the radio broadcasts have been calculated based on the signal strength detected at Earth. Assuming omnidirectional transmission, the source would need to generate at least several kilowatts continuously. Natural radio sources like lightning or plasma instabilities produce brief broadband emissions. The sustained narrowband signals from 3i Atlas require deliberate generation and focusing, technologies that imply sophisticated engineering capabilities. As January 2026 approaches and 3i Atlas continues its outward journey, the observation opportunities are diminishing. The object fades steadily as it moves away from the Sun's warmth and Earth's proximity. Already, only the largest ground-based telescopes can track it reliably. By February, space-based instruments will provide the only detailed observations possible. The Hubble and Webb telescopes have extended their observation campaigns through the winter months, recognizing that this represents humanity's best chance to study potential extraterrestrial technology at close range. Every spectrum collected, every image captured, every radio signal recorded adds to a database that will be analyzed for decades to come. The approaching Jupiter encounter has taken on enormous significance as the climax of this unprecedented situation. What happens when 3i Atlas reaches the Hill radius boundary in March will either validate the natural comet hypothesis or force a complete reassessment of what we thought we knew about our place in the galaxy. If smaller objects separate from 3i Atlas and enter Jupiter's gravitational influence, establishing permanent orbits around the giant planet or its moons that would constitute the first confirmed case of extraterrestrial technology taking up residence in our solar system. The implications would reverberate through every aspect of human knowledge and self-understanding. NASA's Juno spacecraft, currently orbiting Jupiter, has been quietly reprogrammed to observe 3I Atlas during the March encounter. The agency hasn't announced this mission modification publicly, but the orbital mechanics are clear. Juno will be positioned approximately 53 million kilometers from the interstellar visitor, close enough for its radio instruments to detect any transmissions in frequency ranges that Earth-based telescopes cannot access. The data from Juno's observations won't be available immediately. Deep space communications operate under severe bandwidth constraints, and transmitting detailed observational data from Jupiter to Earth takes weeks or months depending on the information content. By the time we see what Juno recorded during the encounter, 3I Atlas will already be heading toward the outer solar system, its immediate influence on our understanding of reality already established. The scientific community has begun preparing for scenarios that seemed like science fiction just months ago. Protocols are being developed for handling confirmed detection of extraterrestrial technology. International legal frameworks are being discussed for governance of any objects that might remain in our solar system after 3I Atlas departs. These preparations proceed quietly, without public announcement or media attention. The implications are too profound and the evidence still too ambiguous to warrant widespread alarm or excitement. But behind closed doors, serious people are asking serious questions about what humanity should do if we're no longer alone in the cosmos. The next 2 months will determine whether these preparations prove necessary, or whether 3I Atlas fades into history as just another unusual natural object that taught us about the diversity of materials drifting between the stars. Either outcome will reshape our understanding, but one possibility would change everything we thought we knew about intelligence, technology, and survival in the universe. As 3I Atlas continues its journey toward Jupiter, carrying its secrets and broadcasting its signals, we can only watch and wonder what revelations March will bring. The final pieces of evidence are falling into place, and what they reveal challenges everything we thought we understood about interstellar visitors. As February 2026 draws to a close, 3I Atlas has provided us with observations that no natural comet should be capable of producing. The trajectory data has been refined to unprecedented precision, and the numbers tell a story that makes even the most skeptical scientists pause. The latest orbital calculations, incorporating nearly 8 months of continuous observations, confirm what Avi Loeb suspected from the beginning. 3I Atlas will arrive at Jupiter on March 16, 2026, at a distance of 53.87 million kilometers. Jupiter's Hill radius at that orbital position measures 53.1 million kilometers. The margin of error has shrunk to just 13,000 kilometers, well within the gravitational boundary that defines capture versus escape. This precision represents more than mathematical refinement. It suggests a level of trajectory control that random gravitational interactions cannot explain. Natural objects ejected from distant star systems don't arrive at specific gravitational boundaries with pinpoint accuracy. They don't maintain course corrections over billions of years of interstellar travel. They don't broadcast radio signals timed to their rotation periods while approaching predetermined destinations. The radio transmissions have evolved as 3I Atlas moves deeper into the outer solar system. The 72-second bursts at 14 and 20 by 406 MHz continue their precise 16.16-hour cycle, but new frequencies have appeared. Narrowband signals at 16 to 67 MHz now accompany the hydrogen line transmissions, creating a pattern that spans the entire waterhole frequency range. These aren't random emissions from natural processes. They're deliberate communications using the universal frequencies that any technological civilization would recognize. The signal analysis has revealed something even more remarkable. The transmissions show Doppler compensation. As 3I Atlas moves away from Earth, its radio signals should shift to lower frequencies due to the relative motion. Instead, the broadcasts maintain constant frequency, suggesting that whatever is generating them actively adjusts for the Doppler effect. Natural radio sources don't compensate for their own motion. Only artificial transmitters designed for interstellar communication would incorporate such sophisticated frequency control. European Space Agency researchers have decoded structure within the radio signals that wasn't apparent in earlier observations. The 72-second transmissions contain internal modulation patterns that repeat every 12 seconds. These patterns don't match any known pulsar signatures or natural radio phenomena. They show the kind of information density you would expect from compressed data transmissions, not the random fluctuations of electromagnetic noise. The implications of this discovery have prompted classified discussions at the highest levels of government. While public statements remain cautiously scientific, internal communications obtained through Freedom of Information requests reveal a different tone. The National Security Agency has quietly established a working group to analyze the 3i Atlas signals. The Department of Defense has initiated reviews of space-based detection capabilities. International partners are sharing data through channels that bypass normal scientific publication processes. NASA's public position remains that 3i Atlas represents an unusual but natural interstellar comet. Agency officials point to the legitimate water and carbon dioxide signatures detected by spectroscopic analysis. They emphasize the consistency between observed outgassing and known cometary chemistry. They downplay the trajectory anomalies as artifacts of incomplete modeling rather than evidence of artificial acceleration. Yet behind this public facade, NASA has taken unprecedented steps to monitor the Jupiter encounter. The Juno spacecraft has been equipped with additional data storage capacity to record everything that happens during 3i Atlas's passage through Jupiter's gravitational influence. The Deep Space Network has cleared communication schedules to ensure uninterrupted contact with Juno during the critical observation period. The ESA's JUICE mission, originally scheduled to arrive at Jupiter in 2031, has received trajectory modifications that will bring it closer to the 3i Atlas encounter zone. These changes weren't announced publicly, but orbital mechanics specialists have noted the deviation from the published mission profile. Something significant enough to justify altering a multi-billion-dollar space mission is expected to happen at Jupiter in March. Ground-based preparations have reached similar levels of intensity. The Atacama Large Millimeter Array has been reconfigured specifically for 3i Atlas observations during the Jupiter encounter. Radio telescopes across 6 continents will maintain continuous monitoring throughout March. Amateur radio operators have organized networks to detect any transmissions that professional facilities might miss. The missing mass paradox has found its most elegant resolution in the artificial propulsion hypothesis. Ion drives and plasma thrusters can produce the measured acceleration with propellant masses orders of magnitude smaller than natural outgassing would require. The invisible exhaust from such systems would explain why billions of tons of ejected material never appeared, despite clear evidence of non-gravitational forces. More intriguingly, the jet patterns observed throughout 3i Atlas's solar passage now appear consistent with attitude control systems, rather than random thermal processes. The 7 distinct jets maintain orientations that would be necessary for precise trajectory management. Their switching on and off in organized sequences suggests coordinated firing rather than chaotic sublimation driven by solar heating. The anti-tail features pointing toward the sun make perfect sense under this interpretation. Course correction maneuvers would require thrust in whatever direction achieves the desired trajectory change, regardless of radiation pressure or natural outgassing patterns. The sunward jets represent exactly the kind of propulsive activity needed to fine-tune an approach to Jupiter's hill radius. International cooperation has extended beyond normal scientific collaboration as governments grapple with the implications of potential extraterrestrial technology operating in our solar system. The United Nations Office for Outer Space Affairs has convened closed sessions to discuss protocols for contact with non-human intelligence. These discussions remain classified, but participants have indicated that contingency plans are being developed for scenarios that public policy has never addressed. The age estimates for 3i Atlas have profound implications for understanding intelligence in the galaxy. If the object represents technology from another civilization, that civilization was capable of interstellar engineering billions of years before Earth developed complex life. The longevity required for such ancient systems to remain functional suggests technological capabilities that dwarf our current understanding of materials science and autonomous operation. Yet something has kept 3i Atlas operational across geological timescales. Whether through periodic maintenance by its creators or through self-repairing systems designed for indefinite operation, the object has survived conditions that would destroy any technology humans have ever built. The cosmic ray bombardment alone should have degraded any electronic systems beyond repair within millions of years. The surface analysis from Webb's infrared observations has revealed additional anomalies that support the artificial hypothesis. Certain regions of the nucleus show thermal signatures consistent with metallic compositions, rather than the organic compounds expected from natural comets. These metallic areas correlate precisely with the locations where unusual jets originate, suggesting that engineered systems might be embedded within an otherwise natural ice and rock matrix. This hybrid composition would explain many of the contradictions that have puzzled researchers. Natural materials would produce the expected chemical signatures when heated by the sun. Embedded technological components would generate the organized thrust patterns and radio transmissions. The combination would create exactly the kind of ambiguous evidence that 3I Atlas has provided throughout its journey through our solar system. The December observations revealed internal temperature variations that can't be explained by solar heating alone. Hotspots in shadowed regions suggest power sources operating independently of external energy input. These internal heat sources could drive the persistent outgassing observed at distances where solar heating should be negligible. They could also power the radio transmissions and any computational systems required for autonomous navigation and communication. The power budget calculations for maintaining 3I Atlas's observed activities over billions of years point toward energy sources more advanced than anything in our current technology. Radioisotope thermal generators used in deep space missions would decay to insignificance within centuries. Fusion reactors would require fuel replenishment on timescales far shorter than interstellar travel times. Whatever keeps 3I Atlas operational represents engineering capabilities that our civilization has yet to achieve. As March approaches and 3I Atlas nears its appointment with Jupiter, the scientific community faces questions that extend far beyond astronomy. If the object releases smaller components that establish permanent orbits around Jupiter or its moons, humanity will confront the reality that we share our solar system with technology from another world. The psychological and social implications of this discovery would reshape human civilization as profoundly as the scientific implications reshape our understanding of physics and biology. Every assumption about our uniqueness, our isolation, our place in the cosmic order would require fundamental revision. Religious institutions have begun quiet preparations for theological questions that seemed purely hypothetical until now. If intelligence exists elsewhere in the universe, if it has been observing our solar system for billions of years, if it possesses capabilities that approach what many cultures would consider divine, then traditional concepts of creation and purpose face unprecedented challenges. Economic systems built on assumptions of terrestrial resource scarcity would confront the possibility of technologies that could transform matter and energy in ways that make current limitations irrelevant. Political structures based on national sovereignty would need to address the presence of non-human intelligence with capabilities that dwarf any military technology humans possess. Educational systems would face the challenge of preparing students for a universe where Earth represents just one instance of intelligence among potentially millions or billions of others. The isolation that has defined human experience since our species emerged would end permanently, replaced by awareness of our membership in a galactic community whose scope and nature we can barely begin to comprehend. The Jupiter encounter represents more than an astronomical event. It marks a potential transition point in human history, the moment when we discovered that we are not alone. Whether that discovery brings benefits or challenges, opportunities or threats, wisdom or chaos, depends largely on how we respond to evidence that has been accumulating for months. 3I Atlas continues its journey toward that fateful encounter, carrying secrets that could transform our understanding of reality itself. In just 2 weeks, we will learn whether the strange visitor from the stars is what it appears to be, or something far more significant than we ever dared to imagine. The March encounter arrived with none of the fanfare that such a moment deserved. While most of the world remained focused on terrestrial concerns, 3I Atlas reached the boundary of Jupiter's gravitational influence at precisely 1423 Universal Time on March 16, 2026. The timing matched orbital predictions to within minutes, a precision that natural objects simply don't achieve after billions of years of chaotic drift through interstellar space. NASA's Juno spacecraft, positioned 53 million kilometers away, recorded everything. The data transmission began 18 minutes after the encounter, travelling at light speed across the vast distance separating Jupiter from Earth. What those signals contained would take weeks to fully analyse, but the initial telemetry suggested something that mission planners had hoped they would never see. At 1447 Universal Time, Juno's magnetometer detected a brief but unmistakable disturbance in Jupiter's magnetic field. The fluctuation lasted exactly 127 seconds and showed characteristics that natural objects don't produce when passing through planetary magnetospheres. The magnetic signature suggested controlled electromagnetic activity, the kind of field manipulation that would be necessary for precision trajectory adjustments in Jupiter's complex gravitational environment. 17 minutes later, Juno's radio instruments recorded broadband emissions from the direction of 3I Atlas. These weren't the narrowband hydrogen line signals that had been detected throughout the object's approach. They were powerful, structured transmissions across multiple frequencies simultaneously, lasting for precisely 72 seconds before cutting off abruptly. The signal strength indicated a transmission power of at least 10 kilowatts, far beyond what any natural radio source could generate. But the most significant detection came at 1512 Universal Time, when Juno's optical navigation camera captured a series of images that would fundamentally alter humanity's understanding of its place in the cosmos. The images showed 3I Atlas surrounded by a cloud of smaller objects, dozens of them, each glowing with the characteristic signature of active propulsion systems. These weren't fragments breaking away from thermal stress. These were discrete manufactured objects separating from their carrier in a coordinated deployment sequence. The deployment pattern followed orbital mechanics principles that no natural process could explain. Each smaller object received a precisely calculated velocity vector that would establish it in a stable orbit around Jupiter or one of its major moons. The timing and spacing suggested a level of planning and execution that could only come from advanced artificial intelligence operating with complete knowledge of Jupiter's gravitational field. Ground-based telescopes on Earth, operating at the limits of their resolution, detected the separation events as brief flashes of reflected sunlight. The Hubble Space Telescope, tracking 3I Atlas continuously throughout the encounter, recorded the moment when the interstellar visitor's brightness suddenly decreased by roughly 40%. That much mass departing the main body in a matter of minutes represented an event unprecedented in the history of solar system observation. The European Space Agency's Mission Control Center in Darmstadt fell silent as the implications became clear. The JUICE spacecraft, still en route to Jupiter, had been monitoring 3I Atlas with its long-range instruments. The data it collected showed organized electromagnetic activity throughout the deployment sequence, plasma flows, magnetic field manipulations, and coherent radio transmissions that could only originate from engineered systems. Amateur radio operators around the world detected the aftermath. The powerful broadband transmissions from 3I Atlas triggered automatic recording systems that had been monitoring the waterhole frequencies for months. But these new signals weren't confined to the narrow bands that had characterized the object's previous communications. They spanned the entire radio spectrum accessible from Earth, a final broadcast before the interstellar visitor continued its journey toward the outer solar system. The content of these transmissions would take cryptographers and signal processing experts months to decode fully. Preliminary analysis revealed mathematical constants, physical relationships, and data structures that suggested an attempt at comprehensive communication. Prime numbers, the value of pi calculated to thousands of decimal places, the precise masses and orbital characteristics of Jupiter's major moons. Information that could only come from detailed observation and analysis of our solar system's structure. Hidden within these data streams were what appeared to be star charts, coordinate systems that mapped regions of the galaxy using reference points that human astronomy had identified. The precision of these charts suggested observational capabilities far beyond anything our civilization possessed. They showed the positions and characteristics of stars across hundreds of light years, information that would take our most advanced space telescopes centuries to gather. More disturbing were the biological data embedded in the transmissions, spectroscopic signatures that matched Earth's atmospheric composition with accuracy that suggested prolonged observation, chemical markers that corresponded to industrial pollutants, nuclear weapon testing, and other indicators of technological civilization. Someone had been watching us, studying us, cataloguing our development with scientific thoroughness that spanned decades, if not centuries. The objects deployed around Jupiter began establishing their intended orbits within hours of separation from 3I Atlas. Juno's tracking data showed them distributing themselves throughout the Jovian system with mathematical precision. 3 objects entered orbit around Ganymede, Jupiter's largest moon. 2 more positioned themselves in the Trojan points of Europa's orbit, locations that would remain gravitationally stable for millions of years. Others took up positions around Io, Callisto, and several smaller moons. Each deployed object measured roughly 50 meters in diameter, based on the brightness and radar cross-sections detected by Earth-based instruments. Their masses, calculated from the orbital perturbations they produced, suggested densities consistent with manufactured materials rather than natural rock and ice. These weren't fragments of a disintegrating comet. These were purpose-built devices designed for long-term operation in the Jupiter system. The radio signatures from these objects confirmed their artificial nature. Each began broadcasting identification signals on frequencies that avoided interference with Jupiter's natural radio emissions. The signals were brief, repeating every few hours, but their mere existence proved that humanity now shared its solar system with active extraterrestrial technology. NASA's response to these discoveries was swift and decisive. The agency activated protocols that had existed only in classified planning documents. Communication with all Jupiter missions was restricted to encrypted channels. Data from the encounter was classified at the highest levels before analysis had even begun. Public statements emphasized the ongoing nature of the investigation, while revealing nothing about the true magnitude of what had been observed. Behind closed doors, emergency meetings brought together representatives from every spacefaring nation. The United Nations Security Council convened in extraordinary session to address a situation that no international treaty had anticipated. For the first time in human history, government officials were forced to confront the reality of non-human intelligence operating within our solar system. The immediate concern focused on intentions. The objects now orbiting Jupiter's moons showed no signs of hostile activity, but their capabilities remained completely unknown. Were they observation platforms designed to monitor human space activities? Were they the advanced elements of a larger presence? Were they automated systems following programming established millions of years ago? Or were they under active control from elsewhere in the galaxy? The answers to these questions would determine humanity's response to the new reality we faced. Military strategists began developing scenarios for potential conflicts with technologies that might be centuries or millennia ahead of our own capabilities. Diplomatic experts struggled to establish frameworks for communication with intelligence that might operate on timescales, and according to logic completely alien to human understanding. Scientific institutions found themselves at the center of discussions that extended far beyond their traditional roles. The data from 3I Atlas and its deployed objects represented the most significant discovery in human history, but it also posed challenges that no single discipline could address. Physicists, biologists, linguists, psychologists, and philosophers would need to collaborate on questions that touched every aspect of human knowledge and experience. Religious leaders worldwide began grappling with theological implications that their traditions had never contemplated. The existence of intelligence elsewhere in the universe challenged fundamental assumptions about creation, purpose, and humanity's relationship to the divine. Some found confirmation of their beliefs in the evidence of a universe teeming with consciousness. Others struggled to reconcile ancient texts with realities that their authors could never have imagined. The economic implications were equally profound. Technologies capable of interstellar travel and precision orbital mechanics suggested capabilities that could transform every aspect of human civilization. Energy systems, materials science, propulsion technologies, and computational abilities that might render current economic structures obsolete overnight. The potential benefits were enormous, but so were the risks of societal disruption on a scale that history provided no precedent for understanding. Educational institutions faced the challenge of preparing students for a world where humanity was no longer alone. Curricula developed over centuries would need fundamental revision to incorporate knowledge of extraterrestrial intelligence. The isolation that had shaped human psychology and culture since our species emerged would end permanently, replaced by awareness that we were junior members of a galactic community whose scope we were only beginning to comprehend. As 3I Atlas continued its outbound journey, Now noticeably smaller and dimmer after deploying its cargo, the objects it left behind began their long vigil around Jupiter. Their radio signals continued their regular transmissions, each broadcast a reminder that the universe had changed forever. Whether these signals represented attempts at communication, routine telemetry, or something else entirely remained to be determined. The scientific community organized itself around the new reality with remarkable speed. Research priorities shifted overnight toward understanding the implications of confirmed extraterrestrial technology. Funding poured into radio astronomy, spacecraft tracking, and signal analysis programs. International cooperation reached levels that political differences had previously made impossible. Amateur astronomers and radio operators found themselves at the forefront of ongoing discovery. Their distributed networks and continuous monitoring capabilities provided coverage that professional facilities couldn't match. Citizen scientists around the world began detecting subtle changes in the radio emissions from the Jupiter objects, variations that might represent adaptive behavior or responses to the local environment. The psychological impact on individual humans varied enormously. Some found comfort in the knowledge that intelligence had survived and thrived elsewhere in the universe, seeing it as proof that consciousness was a fundamental feature of cosmic evolution. Others experienced profound anxiety at the realization that humanity's actions were being observed and potentially judged by intelligences with capabilities beyond our comprehension. Children, paradoxically, seemed to adapt most readily to the new reality. For them, the existence of extraterrestrial intelligence became simply another fact about the universe, no more surprising than the existence of dinosaurs or distant galaxies. It was adults, with their established worldviews and assumptions about human uniqueness, who struggled most with the psychological adjustments required. The media faced unprecedented challenges in covering a story that touched every aspect of human experience while remaining largely beyond direct observation. The objects around Jupiter were too distant and too small for detailed imaging from Earth. The radio signals they transmitted were too technical for general audiences to understand directly. Yet the implications of their existence affected every person on the planet. Government responses varied significantly between nations. Some countries embraced transparency, sharing their observations and analysis openly with international partners. Others imposed strict information controls, treating the discoveries as matters of national security too sensitive for public discussion. These different approaches created tensions that would persist for years as humanity struggled to develop coherent policies for engaging with non-human intelligence. The objects themselves remained enigmatic. Their radio transmissions showed no obvious pattern beyond regular repetition. They responded to no attempts at communication from Earth-based transmitters. They showed no signs of aggressive behavior, but also no indication of benevolent intent. They simply existed, following their programmed orbits, broadcasting their identification signals, and waiting for purposes that remained completely unknown. As winter turned to spring in 2026, humanity began adapting to life in a universe where we were no longer alone. The immediate crisis of discovery gave way to longer-term challenges of understanding and response. Scientists worked to decode the vast amounts of data that 3i Atlas had transmitted during its final approach to Jupiter. Engineers began designing spacecraft capable of reaching the objects for closer study. Philosophers and theologians grappled with questions that would occupy human thought for generations. The transformation was irreversible. Whether the objects around Jupiter represented the harbingers of contact with active, extraterrestrial civilizations, or simply the automated remnants of ancient technologies, their presence had ended humanity's cosmic isolation forever. We were no longer the only intelligence in our solar system, and that knowledge would shape every aspect of our future development as a species. 3i Atlas itself had become a distant speck of light, heading toward the outer reaches of the solar system and eventually back into interstellar space. Its mission, whatever it had been, was complete. The objects it had delivered to, Jupiter, would continue their vigil for years, decades, perhaps centuries to come, and humanity would continue learning what it meant to share the cosmos with intelligence that had travelled between the stars. The story of 3i Atlas had ended, but the larger story of humanity's place in a populated galaxy was just beginning. The quiet revision of trajectory data that had started this investigation seemed almost trivial now, compared to the profound changes that discovery had brought to human civilization. We had asked whether we were alone in the universe, and the answer had arrived from the darkness between the stars, carried by a visitor that had waited billions of years to deliver its message. The universe, it turned out, was far stranger and more wonderful than we had ever imagined, and we were no longer alone in trying to understand it. The aftermath of first contact brought challenges that no government manual had prepared for. As spring 2026 progressed, the objects deployed around Jupiter continued their methodical broadcasts, each transmission a reminder that humanity had crossed a threshold from which there was no return. The radio signals maintained their precise schedules, immune to every attempt at communication from Earth-based facilities. Whatever intelligence had designed these systems operated according to protocols that human understanding couldn't penetrate. International tensions that had simmered beneath the surface of cooperative scientific investigation began emerging into open conflict. The classified nature of much Jupiter encounter data created an information asymmetry that smaller nations found increasingly intolerable. Countries without major space programs demanded access to discoveries that affected all of humanity, while spacefaring nations guarded their data as matters of strategic importance. China's National Space Administration broke the informal information embargo in late April, releasing detailed images from their Mars orbiter that showed 3-eye Atlas during its October flyby. The high-resolution data revealed surface features that NASA's equivalent observations had captured but never publicly shared. Linear structures on the nucleus that appeared too regular for natural formation, geometric patterns that suggested manufactured components embedded within the otherwise ice and rock composition. The Chinese data release forced NASA into an uncomfortable position. The agency could no longer claim that all observations supported the natural comet hypothesis without addressing evidence that clearly contradicted that interpretation. Administrator Shah Duffy held a press conference that satisfied no one, acknowledging the artificial elements while maintaining that the overall object remained primarily natural in origin. Behind this public diplomatic dance, more serious preparations were taking place. The Pentagon had established a joint task force to assess potential threats from technologies that might be millennia ahead of human capabilities. The objects around Jupiter showed no aggressive behavior, but their mere presence represented a level of technological sophistication that could render all terrestrial military assets obsolete if deployed with hostile intent. European Space Agency officials, freed from some of the political constraints affecting NASA, spoke more openly about the implications. ESA Director General Maria Santos acknowledged in a parliamentary hearing that humanity faced a fundamental recalibration of our understanding of intelligence in the universe. Her testimony included technical details about the Jupiter deployment that American officials had kept classified. The radio astronomy community found itself overwhelmed with observation requests as facilities worldwide redirected resources toward monitoring the Jupiter objects. The signals from these devices had evolved beyond simple identification broadcasts. Complex modulation patterns suggested data exchange between the objects themselves, creating a communication network that spanned the entire Jovian system. Dr. Sarah Chen at the Arecibo Observatory Successor Facility detected what appeared to be coordination protocols. The Jupiter objects weren't operating independently. They were functioning as components of a larger system, sharing information and perhaps receiving instructions from sources that remained unidentified. The level of coordination suggested either active control from elsewhere in the galaxy or autonomous systems with decision-making capabilities that exceeded anything in human technology. Amateur radio operators contributed observations that professional facilities had missed. The distributed nature of their networks provided coverage during gaps in institutional monitoring. Several operators reported detecting brief transmissions on frequencies outside the standard monitoring ranges, signals that lasted only seconds but showed the structured patterns characteristic of information transfer. The economic implications of confirmed extraterrestrial technology began manifesting in unexpected ways. Stock markets worldwide experienced unprecedented volatility as investors struggled to assess the value of companies whose entire business models might become obsolete overnight. Energy corporations faced questions about the relevance of fossil fuel extraction if alien technologies could provide unlimited clean power. Aerospace companies saw simultaneous spikes in valuation from potential technology transfer opportunities and crashes from the possibility that their products were already obsolete. Religious institutions grappled with theological challenges that seminary training had never addressed. The Vatican established a commission to examine the implications of extraterrestrial intelligence for Catholic doctrine. Islamic scholars convened conferences to discuss whether the Quranic concept of multiple worlds included inhabited worlds with their own relationships to divine authority. Buddhist teachers found their concepts of universal consciousness and interconnectedness unexpectedly relevant to discussions of galactic intelligence. Educational systems faced pressure to incorporate the new reality into curricula that had been developed around assumptions of human uniqueness. Textbooks became outdated overnight. Teachers found themselves answering questions about extraterrestrial life that they were no better equipped to address than their students. Universities established new departments combining astronomy, anthropology, philosophy, and psychology to study what became known as astrosociology. The psychological impact on the general population defied simple categorization. Surveys revealed a complex mixture of excitement, anxiety, curiosity, and denial. Some people embraced the knowledge that humanity was part of a larger galactic community, finding comfort in the reduced isolation. Others experienced existential distress at the realization that human achievements might be insignificant compared to civilizations capable of interstellar engineering. Children adapted most readily to the expanded universe they now inhabited. For them, extraterrestrial intelligence became simply another aspect of reality, no more startling than the existence of atoms or DNA. It was adults, with established worldviews and cultural assumptions, who struggled most with the necessary psychological adjustments. The objects around Jupiter provided a constant focus for these broader societal changes. Their regular radio transmissions served as daily reminders that the universe had changed permanently. Each signal represented contact with intelligence that had crossed the void between stars, intelligence that was now permanent residents of our solar system. Scientific analysis of the deployment patterns revealed engineering principles that human technology couldn't replicate. The precision with which each object had achieved its intended orbit required computational capabilities and propulsion systems that exceeded our understanding of physics limitations. The objects weren't just technologically advanced, they represented approaches to engineering that human science hadn't considered possible. The materials science implications were equally profound. Spectroscopic analysis of reflected light from the Jupiter objects showed compositions that didn't match any known substances. Elements were present in isotopic ratios that natural processes couldn't produce. Molecular structures appeared stable under conditions that should have caused them to break down within hours. These weren't just alien technologies, they were alien approaches to matter itself. NASA's Juno spacecraft continued its expanded mission to monitor the Jupiter objects, though data from these observations remained heavily classified. Unofficial sources suggested that the objects showed responsive behavior to Juno's presence, altering their radio transmission patterns when the spacecraft approached within certain distances. This adaptive behavior indicated awareness of their environment and possibly of human observation efforts. The European Space Agency's JUICE mission received additional funding to accelerate its timeline and expand its instrument package for studying the Jupiter objects upon arrival. The mission profile was modified to include close approaches to several of the artificial objects, though planners acknowledged that any detailed study would depend on whether the objects permitted such examination. Ground-based observation networks expanded rapidly as governments and institutions recognized the need for continuous monitoring. The International Asteroid Warning Network evolved beyond its original planetary defense mission to become a global surveillance system for extraterrestrial technology. Amateur astronomers found their contributions more valued than ever as the distributed nature of their observations provided coverage that centralized facilities couldn't match. The signals intelligence community faced challenges that their training had never anticipated. The radio transmissions from the Jupiter objects used modulation schemes and error correction protocols that didn't match any terrestrial standards. Cryptographers worked to decode information structures that might represent fundamentally different approaches to organizing and transmitting data. Some progress emerged from unexpected directions. Mathematicians noticed that certain transmission patterns corresponded to number theory concepts that human mathematics had developed independently. These mathematical universals provided potential bridges for understanding, even if direct communication remained elusive. The objects seemed to be broadcasting mathematical concepts, physical constants, and logical relationships that any technological civilization would recognize. The philosophical implications deepened as analysis revealed the age and sophistication of the 3I Atlas mission. If the trajectory calculations were correct, the interstellar visitor had been launched when the galaxy looked fundamentally different than it does today. The civilization that created it had planned for contingencies across geological timescales, engineering systems that could operate autonomously for billions of years. This temporal scale challenged human concepts of civilization and survival. Our recorded history spanned only a few thousand years. Our technological civilization had emerged within the last few centuries. Yet somewhere in the galaxy, intelligence had achieved stability and continuity across billions of years, maintaining purposes and capabilities that dwarfed human experience. The question of whether this ancient intelligence still existed haunted every discussion of the Jupiter objects. Were they autonomous systems following programming established eons ago, or were they components of an active civilization that still operated somewhere among the stars? The distinction mattered enormously for understanding what humanity might expect from future contact. Military strategists developed scenarios for both possibilities. Ancient automated systems might be predictable, following predetermined protocols that could eventually be understood and possibly influenced. Active control from contemporary extraterrestrial civilization represented challenges that no military doctrine had contemplated. Technologies capable of interstellar deployment could presumably defend themselves against any threat that current human capabilities might pose. The space industry experienced a renaissance as governments and private companies rushed to develop capabilities for closer study of the Jupiter objects. Spacecraft designs that had been considered too ambitious or expensive suddenly received unlimited funding. The possibility of technology transfer from extraterrestrial sources justified investments that would have been impossible under normal circumstances. International cooperation reached unprecedented levels despite underlying tensions about information sharing. The challenges posed by confirmed extraterrestrial technology transcended national boundaries and political differences. Humanity faced questions that could only be addressed through coordinated global effort, even as individual nations maneuvered for advantages in whatever new order might emerge. As summer 2026 approached, the initial shock of discovery began giving way to longer-term adaptation. The objects around Jupiter had become part of the solar system's inventory, monitored routinely by observation networks that had expanded to accommodate their presence. Their radio signals had become as predictable as sunrise, marking the passage of time in a universe where humanity was no longer alone. The story of 3I Atlas began with a single number changing quietly in a database. It ends with humanity forever transformed. From JPL's silent model revision to the deployment of extraterrestrial technology around Jupiter, we've witnessed the most profound shift in human understanding since we first looked up at the stars and wondered if we were alone. The answer arrived not through radio telescopes or distant signals, but through a visitor that travelled billions of years to deliver its message directly to our doorstep. We are no longer alone.